Hello and welcome. My name is Evans. I'm going to take you through a packet tracer here about VLAN configuration. It's from CCNA2 version 7. And here we have an addressing table for the devices. First of all, VLANs are very important. They are very helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity focuses on creating and naming VLANs and assigning access ports to specific VLANs. VLANs are virtual local area networks, or virtual LANs, that are introduced in a network. So the objectives are to verify the default VLAN configuration for part 1, and part 2 is configure VLANs, and then at part 3 we are going to assign VLANs to ports. So part 1, view the default VLAN configuration. So display the current VLANs, that's step 1. We are going to, on S1, issue the command that displays all VLANs configured. By default, all interfaces are assigned to VLAN 1. So from our diagram here, we are going to click on S1, enable, and from this mode we can show VLAN brief. As we can see here, we have several VLANs that are already created by default, and VLAN 1 is the default VLAN which is active, and all ports on S1 are assigned to VLAN 1 by default. Then on S3 the same, we can do the same, enable, show VLAN brief. You can see the same, because we've not changed anything. We have the default VLAN is the one that has all the ports. So the second instruction, step 2, we are going to verify connectivity between PCs on the same network. Notice that each PC can ping the other PC that shares the same subnet. So like PC1 and PC4, looking at the PC1 and PC4 are both on VLAN 10, so they share the same subnet, they are on the same network. PC2 VLAN 20 and PC5 VLAN 20, meaning they are on the same network, and when you ping both of them, they can ping because they are on the same network. And PC3 and PC6 are in the same VLAN 30. So if we ping PC4 from PC1, sorry for that, PC1 and PC4, so let's copy the address of PC4, and then from PC1 command prompt we can ping the address of PC4. As you can see, we are getting replies, meaning the pings are successful. We have 0% loss. And again from PC2 we can ping PC5, which is 20.25. And as you can see, we are getting replies. And finally from PC3 we can ping PC6 30.26. .30.26, and as you can see, we are getting replies from PC6. So that basically shows that hosts on the same network or in the same VLAN can ping each other. And then the next thing that we're going to do is pings to hosts on other network fails. Because they are not on the same network, we can try pinging PC 6 from PC 1. It's 30.26, and you can see we get a timeout, request timed out. The pings are not going to be successful because the hosts are not on the same network. Great. What benefits can VLANs provide to the network? As you can see in our network, VLANs are helping to break a broadcast domain, and that helps in reducing the traffic in the network, because hosts on one VLAN can only communicate with other hosts in the same VLAN. They cannot broadcast to other hosts in different VLANs in the same physical network. So that helps in reducing traffic in the network, as well as also applying security measures in different VLANs, like access list. People in the, for example, in the administration have one VLAN, and for example in a school setup, the students have their own VLAN, so the students cannot see or they cannot access the hosts that are on the administration VLAN. Part 2, we're going to configure VLANs. We're going to create and name VLANs on S1. Create the following VLANs. Names are case sensitive and must match the requirement exactly for us to get 100% in the activity. So VLAN 10, we are going to S1. We create a VLAN 10, and we are going to name it faculty/staff. So S1, we have to go to the configuration mode, config T. We're going to create VLAN 10, and then we name it faculty/staff. Faculty/staff. Then we create the remaining VLANs. VLAN 20, we name it students. We can exit. VLAN 20, we name it students with an S. Then we exit. Then we create VLAN 30, and we name it guest into brackets default. Guest into bracket default. We have VLAN 99 management and native. We name it management and native with a capital N. Sorry. Exit. And then we create VLAN 150. We name it voice. We name it voice. We can copy running startup. From there, we verify the VLAN configuration, which command will only display the VLAN name, status, and associated ports on a switch that is only VLAN. Show VLAN brief. We confirm that. Show VLAN brief. As you can see, we have the added VLANs, faculty, and we have students, VLAN 20, VLAN 30 guests into bracket default. We have VLAN 99 as management and native. We have VLAN 150 voice. But remember that all the ports are still on the default VLAN, which is VLAN 1. From there, we can create the VLANs on S2 and S3. Use the same commands from step 1 to create and name the VLANs on S2 and S3. So we're going to create all those VLANs on S2 as well. So S2, enable configure terminal. So we have VLAN 10 and the name is faculty / staff. Exit. We have VLAN 20 and the name is students. We have VLAN 30. Name it guest into bracket default. We have VLAN 99 and the name is management. And native. We have VLAN 150, which is voice. We exit again, and now we copy running config startup config to save the commands or to save the configuration. Then we do the same on S3. Enable config terminal. VLAN 10, we name it faculty / staff. We exit. We create VLAN 20 and we name it students. And we exit. We create VLAN 30. We name it guest default. We exit. We create VLAN 99. We name it management and native. And then we create VLAN 150 and we name it voice. We copy running config startup config to save the configuration. From there, we've created and named the VLANs. Now we are going to verify the VLAN configuration. The command that will only display those VLANs, we did that. Let's now confirm. We verify the VLANs on S2 and S3. So from S2, we can show VLAN brief. As you can see, we have the extra VLANs that we've created on S2. The same happens on S3. We can show VLAN brief. As you can see, we have VLAN 10, 20, 30, 99 and 150 that we've created already. So we now go to step part 3. We're going to assign VLANs to ports. So we assign VLANs to the active ports on S2. We configure the interfaces. Remember, the active ports on S2 are Fast Ethernet 11, Fast Ethernet 18, and Fast Ethernet 6, and also Gigabit 01. Those are the active ports on S2, and each port has its own VLAN. Fast Ethernet 6, it's on VLAN 30. Fast Ethernet 0/18 is on VLAN 20. Fast Ethernet 011 is on VLAN 10. So we are going to assign those ports to those VLANs. So this is the way we do it. For Fast Ethernet 011, we are going to assign it to VLAN 10, and we do that by interface Fast Ethernet 11. We go to the interface, then we set that port, switch port, as an access port, and then we allow it to access VLAN 10. So we start with Fast Ethernet. This is on S2. Config T. We go to the interface Fast Ethernet 0/11. Yes. Then switch port mode access. We make that port an access port. Later we will see different other types of ports. And then switch port access VLAN 10. We are now setting that port, switch port, to access VLAN 10. We have other ports, other interfaces. We have Fast Ethernet 18 for VLAN 20. So we go to interface, we can exit, go to interface Fast Ethernet 0/18. On that interface, switch port mode access, and finally switch port access VLAN 20. We have also Fast Ethernet 6/06 to access VLAN 30. So we have interface 0/6, switch port mode access, and then switch port access VLAN 30. And now we are done with switch 1. We copy running configuration to startup. We are saving the configurations. After that, we assign VLANs to the active ports on S3 now. Fast Ethernet 11 to VLAN 10. S3 config T. So interface Fast Ethernet 0/11. Switch port, we set its mode as access port, and then switch port, we allow it to access VLAN 10. We exit that interface. We have another interface on S3, Fast Ethernet 18 for VLAN 20. So interfaced Fast Ethernet 0/18 for VLAN 20. So So it's a switch. We make it an access port, and then we allow it to access VLAN 20. We have another port, fast Ethernet 6, interface fast Ethernet 06, switch port mode access, and switch port access VLAN 30. Yes. Then you're going to assign the voice VLAN to fast Ethernet 011 on S3. So as shown in the topology, the S3 fast Ethernet 011's interface connects to a Cisco IP phone and PC4. The IP phone contains an integrated 3-port 10/100 switch. One port on the phone is labeled switch and connects to fast Ethernet 04. Another port on the phone is labeled PC and connects to PC. As you can see, it has a port named switch and a port named PC. That's what the instruction talks about. Another port on the phone PC connects to the PC. The IP phone also has an internal port that connects to the IP phone functions. The fast Ethernet 11 of S3 interface must be configured to support user traffic to PC4 using VLAN 10 and voice traffic to the IP phone using VLAN 150. The interface must also enable QoS, that is quality of service, and trust the class of service values assigned by the IP phone. IP voice traffic requires a minimum amount of throughput to support acceptable voice communication quality. This command helps the switch port to provide this minimum amount of throughput. So we go to S3 and fast Ethernet 11. Then we're going to offer this command MLS, quality of service trust, and then class of service. MLS, quality of service. Remember, quality of service is so that it can allow the voice and give it priority whenever it's needed. And then from there, now we can assign the voice to VLAN 150 switch point voice. VLAN 150 is the one that we're going to set as voice. Now we're going to verify loss of connectivity. Previously, PCs that share the same network would ping each other successfully. Study the output of the following command on S2 now and answer the following questions based on your knowledge and communication between VLANs. Pay close attention to gigabit Ethernet, gigabit 0/1 port assignment. On S2, we are going to show VLAN brief, and when we show it, they have given us an output here to show that port 11 is on VLAN 10 and port 18 is on VLAN 20, port 6 is active on VLAN 30, and voice is active on VLAN 150. We are going to try now to ping again PC1 and PC4. PC4 is .10.24. We have that command somewhere here. We are getting a timed out, meaning they are not pinging one another and in the same VLAN. So although the access ports are assigned to the appropriate VLANs, were the pings successful? Of course no. We're going to explain that, what could be done to resolve this. For an explanation of that is that we have configured VLANs on PC1 and PC4 and S2, S1 and S3. But now, what about fast Ethernet 11 of gigabit 1 and gigabit 1 of S1 and S2 and S3 as well? This must be configured to allow multiple VLANs, because only all VLANs are allowed on this link here. This link should allow all the communication from VLAN 10, VLAN 20, VLAN 30 to go across. And that's the next topic that I'm going to handle on trunking. We must configure this as a trunk to allow multiple or many VLANs to cross that link. So that's the simple explanation about it. We have to configure trunks on those links that connect the switches so that they can allow multiple VLANs to pass through those links. Thank you so much for watching that video. Subscribe, and I'm going to post the next video shortly on trunking. Thank you. My name is Evans.